Okay, we are on lesson 8. Lesson 8 is titled Data Persistence, but to start lesson 8, I want to refresh everyone about our lesson 5 exercise. So for our lesson 5 exercise, we built this bank account application that allowed a user, or better yet, forced a user to set up a bank account, and then the user could then deposit and withdraw money from that bank account. So I'll just run this app just to remind everyone how it works. So account holder name and social security number. Okay. And so we've set up our account and we can deposit into the account. So deposit 500 and then we can withdraw from the account. And withdraw 100 and check balance. Okay, our balance is now 400. And the big problem with this app is that if I leave the app and then I run it again, right? So for one, it doesn't remember me. It doesn't remember my account that I set up. And two, it doesn't remember the balance in my account, right? So all the money that I put in this account is now obliterated and I have to start all over. So this is the problem we want to solve with lesson 8. And we're going to solve that by talking about data persistence. Okay, so with that, we'll transition to some slides. Okay. So here is our developer tool diagram, and we've added some new tools to the diagram. So we've added this file system tool, so we're going to talk about the file system. And we've also added this JSON icon to our diagram. So these are two new things we're going to introduce in order to implement data persistence in our applications. Okay, so the important thing we want to observe is that apps tend to be short-lived. So in particular, app is a generic word, but let's think about an app meaning like our lesson 5 council application that we just showed, or an app meaning like maybe some app you would install on your smartphone, right? So these types of apps are used in durations of seconds to minutes or hours, right? So if I think of my Wells Fargo mobile banking app, I might open that app and it'll be open for 45 seconds to check my bank account, and then it's gone, it's closed. So it's short-lived, okay? The usage is short-lived. It doesn't exist perpetually. So we just need to acknowledge that because we have to realize that that app is clearly not responsible for maintaining the data that exists in the system, right? So Wells Fargo, for example, I don't need the Wells Fargo mobile app in order to have a Wells Fargo account. The Wells Fargo account needs to exist elsewhere, and I just use that app. I just use that Wells Fargo banking app to interact with their system. So really, in that sense, the app's only goal is to provide the code for interacting with the system, to provide the interface, okay? So with that observation, let's talk about persistent storage. So persistent storage is a generic word that just means it's a mechanism to store data indefinitely. So Wells Fargo needs to indefinitely store all the information they have about your bank account. And your app is just being responsible for accessing this information in order to show you, right? So the app just provides the interface, but the persistent storage mechanism will store that data indefinitely. And there's a lot of options for persistent storage. So relational databases, NoSQL databases, S3 buckets, AWS S3 buckets. So these are all good options, and used very commonly, frequently in large-scale applications. But this last one here, file systems, is the one we're going to focus on today. So the file system is, right, just as you use your file system to store Word documents or whatever, we're going to use the file system to store our data indefinitely about our application. Okay, so now let's show this visually. So what we're saying is we may have this mobile application, so in this case a Wells Fargo banking application, and we're saying that this mobile application needs to contact this persistent storage mechanism in order to save and retrieve data. So think of this arrow as like a method call, right? So the Wells Fargo app will make a method call to the storage mechanism to save data, and in that case, the storage mechanism might not return anything, right? It just says, okay, I saved it. Or it might make a method call to retrieve data. So the app makes the call, and then the storage mechanism returns the result, right? So it'll make the call to retrieve the data, and the storage mechanism will return the data. Okay, so think of this arrow as a method call. Okay, so visually that's what we want to do. But now let's bring it to our specific solution for our Lesson 5 exercise. So in particular, we have our Lesson 5 console application with a bank account here, and at some point we need to contact the file system to save data or to retrieve data. So, and just think about a file on your computer, right? So in this example, this application is contacting the file system to get data from this file on the machine, right? Located in this location. Okay? Okay, so the next thing we want to understand is that, say our application created some C# object, and we want to ask the file system, hey, file system, can you save this C# object so that the next time this app runs, I can get my object back? Okay, and what we need to understand is that the file system doesn't know how to save C# objects, right? It doesn't know what that is. But it does know some things, right? So it knows if you give it some text, it knows how to save text. Or if you give it a series of ones and zeros, right? This is how computers store information internally. If you give it a series of ones and zeros, like, oh, I can store ones and zeros, that's fine. So we need to transform our C# object into something that our file system can store, and we will call this process, this transformation, serialization. Okay, so for the purposes of our course, serialization is going to be the process of transforming an object into text, and it's helpful if the text that you give the file system follows some standard format. So here's some common standardized text formats, right? Comma-separated values. So you could think about an object as a series of values that are comma-separated. You could think about it in terms of XML. XML is again, it's just text, but it takes a specific format. And then, of course, the text format we're going to look at today is JSON, or JavaScript Object Notation. And again, it's just text, but it follows a specific format. Some other things you could do, right? Some other formats is, of course, you could convert your object into a series of ones and zeros, or binary, and that works for your computer, but it's not very human readable. Like, you wouldn't be able to open this file on your file system and read what it says. Excel, I mean, in theory, you could store objects in an Excel document. So it's possible, but again, what we'll focus on is JavaScript Object Notation. So JavaScript Object Notation originated in the web development world, and it was used to communicate data between your client application and your server application. So your client application is is what your user interacts with. So this is running in your web browser, Mozilla Firefox, Microsoft Edge, Google Chrome, whatever web browser is installed on someone's local machine. It's running this app, and this app needs to communicate with the server, which is located in the cloud or at a data center somewhere. And to communicate between the two, the client application and the server would use JSON text to do this. Okay, so this is how it looks. This is an example, and hopefully it reads pretty intuitively. You have some properties. So first name's John. Last name's Doe. Age is 35. This is his birth date, and this is his primary car, right? So it should read intuitively, and you don't need to know how to write this for our course, but you should be able to read it and understand what data is there. Okay, so let's look at an example. So on the left side, we have a C# object, right? So we have our class that defines what information is part of a dog, but there is no dog object until we create a new dog, and we give it some data, right? So we give the dog a name, give the dog a breed, we give a dog a birth date, and we serialize this C# object, this dog object, to JSON. We serialize it to JSON, and this is what it'll look like. This is what we want it to look like. Name, Mando, breed, lab, vaccinations, list of strings here, and birth date here. Okay, so that's the goal. Given an object, convert to JSON. That's serialization. Okay. Now, on the other end of that, or the opposite of serialization, is deserialization. So that means, going in the opposite direction. Say you have a JSON text. Convert that JSON text back into one of these dogs here, one of these C# objects. Okay, so we have serialization and deserialization. Serialization means convert to text. Deserialization means convert back to C# object from text. Okay, so with that, we will move on to the exercise to actually see how we do this. Okay, so for the exercise, we'll hop back over to the lesson 5 exercise as our starting point, and we want to take our bank account here, so this account object, from our lesson 5 exercise, and we want to serialize it to JSON text and then store that JSON text in a file somewhere on the computer or on our local file system, so that we can retrieve that object the next time the app runs. So to do that, first we will want to pick out some place on our machine. So I'm going to pick out this folder here. So this is the location on my machine. I want to save this bank account, and so I'm going to copy this path here. And now we need some way to tell our program where we want to save this file. So traditionally we could do something like this, like create a variable and ask the user where do you want to store the data, right? So we could do this and then expect a file back, but this is kind of a weird question to be asking a user. Okay, so let's get this information in another way. Okay, and that other way we're going to do is through this string array args here. So this is our parameter for our main method that we've conveniently been ignoring so far in this course, but now we're going to actually take input through this string array argument parameter here. So let's inspect this here. So I'm going to run this code here and inspect what is in string array args. Okay, so frozen the code on line 6 using the debugger. I hover over this and I see, well, there's nothing in here. It's a string array, sure, and the string array contains no elements in the array. So we want to pass in data through this array now. So to do that, what we can do is, you see here in Visual Studio, there's this little arrow to the right of the play button here, this play button. Click down the arrow, and we can click less than 5 exercise code debug properties. Okay, debug properties, and we can paste in that that file path here. And additionally, so this is the path to the folder. We want to put a file name at the end here. So I'm going to call it datafile.json, right? And to be clear, this file does not exist yet. Okay, datafile.json does not exist in this folder. That's something our app is going to need to create. Okay, but now one more important point here is we need to wrap this in quotes. If we don't wrap it in quotes, we're going to run into trouble. So in quotes, we have the path to our file. Okay, so now we can close this window, and let's put that breakpoint back here, and let's run this again. And now you'll see when we hover over args, now our string array contains one element, and if we expand and look at this element, and we can see it right here. So here it is. We've successfully passed the path to our data file to the program. Okay, so now let's do this just to make things a little more deliberate. So data file equals args 0, right? And if we want to be even more careful, we can check if args dot length doesn't equal 1. Do something like this. So if args.length doesn't equal 1, we can do console.writeLine expected exactly 1 program argument, a path to the data file. Okay, good. And then if this was true, then we can do application dot exit. Oh no, it's environment dot exit. Okay. Okay, good. So now we'll have our data file in this variable data file. Okay, good. Looks like that's working. And so now, I guess just to illustrate a little bit further, if we took this out now, if we took this command line argument out and we run it, we now get an error. We return an error saying this program does not have the program argument that we're looking for. Okay, I'll put that back. Okay, so now let's move on. So the one thing we're going to need to do is we're going to need to serialize our account into text, right? And so let's do that. So serialized account equals, right? So our account is in the account variable, okay? And to serialize it, we can use our good friend, the JSON serializer. Ooh. Hold on. The JSON serializer. Okay, and we can go dot serialize. And then what are we serializing? The account. Okay. So this should convert our account to JSON text, and then we can do file dot write all text. Okay. Oh, sorry. So write all text is a static method, and it takes in two arguments, the path and then what you want to put at the file. So the path is data file. Okay, so we have data file and then the serialized account. So let's just try this out. Okay, so we got our program running. Okay, so now when we do exit, I'll set a breakpoint here. When we do exit, okay, we hit this breakpoint. We have our account. We serialize the account to JSON here. So here we can see our variable now has some JSON in it. And we write the text to the file. So we can just execute this line, and you'll see now in this folder we have our data file.json. Okay, so now if we open this file in just Notepad, we can see that the text that was in our variable is now in this file. And if we inspect this a little more carefully, we can see we have our account holder name, and we have a value here, Ryan, and we have our social security last four, and we have our value here, and then we have our balance in US dollars, and we have our value 400. Okay, so the data that was on that object made it to this file, more or less. Okay, so with that, let's restructure the start of our program so that if we have data in our file, we want to recreate our bank account object from the data in that file. So to do that, I'm going to rework this a little bit. So we want to first ask if the file exists, right? So file, so we have a static method here, file.exists. That tells us whether the file at this path exists, right? And if it doesn't exist, that means this app has not been ran yet, right? Because we don't write the file until this app successfully exits. So if it doesn't exist, the file has not been ran yet, and we can do this same logic that we set up here. Okay. Otherwise, we want to read the data in the file. So saved data. And to do that, we can do file.read all text and give it that path to the file. Okay, and so save data. So that should get our data, and then we want to set our account. Well, okay, so we're gonna have to rework this a little bit here. So I'm gonna pick this up here. I'm gonna copy this here, and I'm gonna define this variable up here. Okay. And so if this is the case, then to convert our saved data back into our object, we can go JSON deserializer. JSON serializer dot deserialize, and now these angle brackets are going to come back here. So we use the angle brackets when we make lists. We have to say list, and then in angle brackets we have to say the kind of object that this list is containing. And we're doing something similar here. We're saying we want to deserialize our saved data, which is just a string. We want to deserialize this back into a C# object, but we additionally have to tell the deserialize method well, what kind of object do you want to deserialize to? Do you want to deserialize to a bank account or to a cookie or to a student, or what type of object are you deserializing to? So that's what we're telling here. And these are, this angle syntax, or kind of what we're doing here, is generally referred to as generics, okay? We can deserialize to anything, but you have to tell us what you want us to deserialize to in the angle brackets. We can create a list for anything, but you have to tell us what kind of list or what kind of object this list is containing. And so we give that information through the angle brackets, and that's called generics, okay? All right, so anyway, let's see how we do here. So I'm going to copy this line here, and then I'm going to change the messaging here. So account for $sign here, account for account dot account holder name. Now the account was already established, so we'll just say retrieved here. Okay, so let's see how we do here. Let's run this and see if we can pull the data from our file back into our program. Okay, so we've hit our else. We can execute this. Okay, good. We have our string, our JSON text, and now let's execute this line, JSON serializer dot deserialize. We got an error here, and the error is interesting. So it says system.invalid operation exception. Each parameter in the deserialization constructor on type lesson 5 exercise code .bank account must bind to an object, property, or field on deserialization. Each parameter name must match with a property or field on the object. Fields are only considered when JSON serializer options.include fields is enabled. The match can be case insensitive. Okay, so we have one hell of an error message here, and it's really not helpful for what's going on. So what this is saying is, or effectively what this is saying is, we're trying to create a bank account object. We're trying to deserialize and create a bank account object for you. But when we go to create a bank account object, we don't know how to make it, right? So the only way you can make a bank account object is by calling this constructor that takes these two parameters. And there's really no good way to say, there's no really good way to tell the deserializer, like, hey, given this data, can you pass these two pieces of information through the constructor to first make the object and then go from there, right? There's no good way to say that. So what we're going to have to do here is we're going to have to add a default constructor back, okay? So we added default constructor back, and the JSON deserializer will call this constructor to make a bank account. And now we're kind of backtracking about what we talked about earlier, though, right? So the reason we created this constructor in the first place was so that we ensured that we had data for these two pieces of information when a bank account was created. And now, because we added this default constructor, we no longer have that guarantee. Okay, but nonetheless, we're going to do it because the JSON deserializer needs it. Okay, so let's try this again. Okay, we pull in our saved data, we try to deserialize, create a new bank account, and the line works. We don't get an error. But if we hover back over our object, we see there's precisely no information. No information made it from our string here. No information made it from this string into our deserialized object. Okay, so think from the perspective of the JSON deserializer. The JSON deserializer sees that I have this property called account holder name, and it has a value, and I want to take that value and put it on the object. Okay, so the JSON deserializer is going to go and do that, but when it finds the property that it wants to put the value on, there's no set, right? So it can't take the value from your text and put it on the object because there's no set. So we're going to have to add a set here, right? Again, going against what we talked about previously. But once we add the set, let's see how we fare. Okay, we execute. And boom, now we've retrieved the name from the text, and our object has been populated with this value. Okay, and now our message should work here, right? That we had retrieved our account. Okay, but we still have more problems here. We still don't have the balance in US dollars, right? That should be what we've saved off is 400. Okay, so now let's fix that one. So we go back, and again, from the perspective of the JSON deserializer, it sees that it has the value 100 or 400 in the JSON, but it can't put it on the object because the set is private. Okay, and you'll have an impossible time like telling the JSON deserializer that you have to call the deposit method in order to manipulate this property, right? You're not going to be able to do that. But what you can do is just care less about encapsulation, and we can take this private off here. Okay, so we take the private off, and we run it again, and I must not have had the breakpoint set. Let's put that breakpoint back, and now we run it again. And now we've taken the private off of that one, and now you see we're able to successfully get back the account holder name and the balance in US dollars. Okay, good. But now we still have another issue. Social Security last four and Social Security number. These Social Security last four errors and Social Security number again doesn't have a value. So let's review again from the perspective of the JSON deserializer, and Social Security last four is a dependent property, right? So it doesn't hold any information by itself. It just manipulates information that exists. So it's not going to help to put a set on this property. Okay, but so let's focus on Social Security number here. Social Security number is a private field, and the JSON serializer cannot see your private fields. So what we're going to do here is, again, go back on encapsulation, and we are just going to promote this thing to a public property. Okay, so I need to rename it. The best way to rename something is to hold control. So highlight it, hold control, and then hit R twice. Control RR. And that will rename it everywhere it's referenced. So you'll see it's changing everywhere. Okay, press enter. So now we've followed the naming convention for public properties, and we're just going to throw our get set here. Okay, good. So now this should be accessible to the JSON serializer. But what we're going to have to do now is, if we see here, in our data file, we haven't saved off the last four of the social. So we haven't saved off the whole social, only the last four, because the whole social wasn't accessible. Okay, so now what I'll do to address that is I'm just going to delete this file so that we start fresh again. Okay, so let's try that. Starting fresh. Okay, Okay, exit, and then if we look at this string, now it has the full social security number along with the last four, and then those other two pieces of information as well. Okay, so and just to verify that it all made it here, so we'll open the file and we'll see exactly what we just saw in our variable. Okay, so now let's retrieve and deserialize. Okay, you'll see our text has all the information we need, and when we deserialize, our account will be fully populated with all our information. So we've completely restored the object from text. Okay, and we can continue now and use the app. Okay, so 400, let's deposit another 200 and withdraw 50. Okay, so we have a balance of 550. We exit. Okay, we exit. We launch the app again. And we see we've retrieved Ryan's account. And when we check balance, the balance is 550. So we picked up exactly where we left off when the app was restarted. Okay, so we've solved the data persistence problem here, but it did come at a cost. We had to essentially get rid of our private fields, make them all public properties, both with public getters and public setters, and we had to add a default constructor. And so we can't ensure that when we have a bank account, these two pieces of information are on the bank account, because you can create one and not add this information now. So it came at a lot of cost, and it broke our encapsulation that we claim to be so important from the previous lesson. So keep that in mind. But you know, for now, for today, our problem is solved.